Tell us your name and tell us about your project.
My name is Maria Goeppert Meyer. During World War II, the U.S. was trying to develop nuclear weapons to end the war. I worked on isotope separation during the Manhattan Project, which was originally named the Manhattan District, because it started as an Army-managed project in New York, but it was later adopted as a code name for the entire project. We started the project in 1939 and had over 130 people across the nation working on different parts. The project even had a department in charge of finding out information about the German project to develop nuclear weapons. We successfully detonated the first bomb in July 1945 in New Mexico during the Trinity test. The next two important bombs were the ones that ended World War II. They were nicknamed Little Boy and Fat Man, and were dropped on the cities of Hiroshima and Nagasaki in Japan, effectively ending the war. Later, our project had more domestic research, like medical, but it still worked on atomic research until 1947.
What were you guys trying to do or find?
Well, the point of the Manhattan Project was to produce two types of weapons, one being a fission gun type weapon and the other an implosion type nuclear bomb. They were conducting uranium enrichment to separate uranium-235 isotopes. We use three methods, which are electromagnetic, gaseous, and thermal. The project was also developing plutonium by irradiating uranium by process of chemically separating the plutonium from the uranium using the bismuth phosphate process. And this led to the creation of an implosion type weapon made from the plutonium.
Where did the project or experiment occur?
The project was spread across the country. But Oak Ridge, Tennessee was called Clinton Engineer Works in 1943. Oak Ridge was the home of the uranium enrichment plants, K25 and Y12, the liquid thermal diffusion plant S50, and the pilot plutonium production reactor X10 graphite reactor. The testing and laboratory work were done in Albuquerque, New Mexico, at the Los Alamos site, and that started in 1942. The site was referred to as Site Y. Chicago, Illinois was the initial location of the pilot plant, but it was later built in Oak Ridge. The research and development of plutonium production were kept in Chicago at the metallurgical laboratory, and the first nuclear reactor took place beneath the bleachers at the University of Chicago. It was created by graphite blocks and uranium pellets. A square balloon was made by Goodyear to hold the reactor. The self-sustaining nuclear chain was called the Chicago Pile 1, and it happened in December of 1942.
What other significant events were happening around the world at that time?
Well, during that time, World War II was everything. It raged from 1939 to 1945. All the world powers took sides for either the Allies or the Axis powers. The Allies consisted of France, Poland, United Kingdom, United States, the Netherlands, Belgium, Greece, Yugoslavia, China, and the British Commonwealth, also the Soviet Union. And the Axis powers consisted of Germany, Italy, and Japan, with many other countries, even those as close as South America, being sympathetic to Germany. The resources from the countries involved were sunk into war efforts. There were over 80 million people killed during the war. It lasted until the surrender of Germany on May 8, 1945 to the Allies, but Japan wouldn't surrender, and we dropped the bombs on Hiroshima on August 6th, and then another on Nagasaki on August 9th. And then Japan ended up surrendering on August 15th, 1945.
Who else was involved in the project?
Well, many people of the scientific community were involved in the Manhattan Project. There were scientists, physicists, engineers, and many workers that spread across several sites. In addition to the locations at Oak Ridge, Chicago, Hanford, and Los Alamos, there were American sites in California, Massachusetts, Colorado, Michigan, Ohio, and several others. Outside the U.S., Canada and Great Britain contributed to the project. J. Robert Oppenheimer was project lead, and with the help of several physicists, they developed the plan for the atomic bomb. Enrico Fermi led the Chicago Pile 1 project to create the first nuclear reactor. Glenn Seaborg, he isolated pure plutonium to use in larger scale. These men continued working on bomb development throughout the project, as did so many others.
What was your role in the project?
Well, my role in the project during the Manhattan Project, I worked at Columbia University Substitute Alloy Materials, short for it's SAM, on isotope separation for Harold Urey. While at Columbia, I researched the chemical and thermodynamic properties of uranium hexafluoride and investigated the possibility of separating isotopes by photochemical reactions. Although it wasn't until later, when lasers were created, that this was going to be possible. In 1945, I transferred to Los Alamos to work, and I worked with Edward Teller on the development of the bomb until later that year. I continued working with Teller after the war in Chicago.
What impact did your project have on the physics community?
The Manhattan Project has impacted physics positively by paving the way for nuclear power, nuclear medicine, and in space exploration. For example, to power the Mars rover with plutonium. It unfortunately has opened the door for other countries with bad intentions to develop nuclear weapons and jeopardizes nations around the world.
During most of your career, you were unable to take a paid position as a physicist because of the anti-nepotism laws at this time, but you were still able to do volunteer work and win the Nobel Prize for Physics in 1963. Tell me about your research and why it meant so much that you would continue it with the laws of the time preventing women from working.
Although it wasn't an ideal situation, I didn't mind because I was doing what I love. During the war, everyone had a part to play, and it was what I knew how to do best. I did have a paid position in 1941 teaching science, but the United States joined the war in 1942, and I joined the Manhattan Project then. In 1946, my husband started work in Chicago as a chemistry instructor for the university, and I took a volunteer position as a physics professor. Later that year, Teller came to work in Chicago, and the Argonne National Lab was built, so I went to work for him part-time. During that time, I developed a mathematical model for the structure of nuclear shells that was published in 1950. It explained that the numbers of nucleons in atomic nucleus results in particularly stable configurations. These numbers are 2, 8, 20, 28, 50, 82, and 126. I figured out after a question was posed to me by Enrico Fermi about possibly it could be due to spinning orbit coupling, where the nucleus is a series of closed shells and pairs of neutrons and protons usually couple together. I was honored to be the second female to win the Nobel Prize in Physics, an achievement that didn't even happen again until 2018. Argonne National Laboratory presents an award each year to an outstanding woman scientist or engineer, and the American Physical Society presents an award in my honor to a young female physicist. I have had postage stamps created in my honor, and I was also inducted into the Women's Hall of Fame in 1996.